Hi everyone. So last time we talked about different types of concentrations. We talked about mass percent, volume percent. There was also mass volume percent and molarity. So today we're going to use molarity as a conversion factor to solve some problems. So remember, molarity has the units of moles of solute over liters of solution. Okay, and we can abbreviate that as a capital M. So down below, let's say we have a solution of hydrochloric acid and the concentration is 3.5 moles per liter. So what that means is for every 1 liter of solution, we have 3.5 moles of hydrochloric acid. Now remember, equalities can also be written as conversion factors. So we could put 3.5 moles of hydrochloric acid in the numerator or in the denominator. It just depends on what we're solving for. So let's do a practice problem where we use molarity as a conversion factor. So how many grams of AlCl3, or aluminum chloride, are needed to prepare 125 milliliters of a 0.15 molar solution? Okay, so visually what this looks like, we have a solution in a beaker. We want that volume of the solution to be 125 milliliters. And then we want to add enough aluminum chloride so that the concentration is 0.15 moles per liter. So how much aluminum chloride should we add? And we want that in grams. Okay, so I'm also going to write out what we're given. So again, we're told that we want the final volume of the solution to be 125 milliliters. And we want the concentration of the solution to be 0.150 moles per liter. So what we need to find out is how many grams of aluminum chloride we need to add to 125 milliliters of water. Okay, so our plan, first of all, we should probably make sure all of our units are the same or at least match up so that we can cancel them. So I'm going to rewrite this capital M as moles per liter just so we can keep track of units. So already I noticed that we have milliliters and liters for the volume amounts. So we should probably convert one of those volume units to the other one, just so they match. So in step 1, let's convert milliliters to liters. So we'll convert 125 milliliters to liters. And then in the second step, we can cancel liters and end up with moles. So we'll multiply the volume of solution, and that's just an abbreviation for solution there, SOL''N. So we'll multiply that by 0.150 moles of aluminum chloride over 1 liter of solution. And then that will give us moles of aluminum chloride. And that will be the amount of aluminum chloride we need to make our solution. However, we were told that we need to figure out the amount in grams. So for our final step, we'll convert moles of aluminum chloride to grams of aluminum chloride. And how do we convert from moles to grams? What handy tool do we have? Molar mass. Okay, so we'll also have to calculate the molar mass of aluminum chloride at that point. Okay, so let's actually start going through this whole process, and it's okay if this is a little confusing. I've been doing this for years, almost like over a decade. So, to me, this is second nature, but you're just starting to learn this information. So if it is at all confusing how I got that information, don't worry. We're going to do a lot of practice problems so you'll get a good idea of how this works. And when you go on to general chemistry, you'll also get a lot of practice with this type of problem. Okay, so let's start with our first step. We're going to convert 125 milliliters to liters. Okay, so we're going to try to get the unit of liters. We're going to cancel the unit of milliliters. So what's the relationship between liters and milliliters? I guess the first question is, which unit is larger? Are liters larger or are milliliters larger? So liters are larger, right? So that means there's going to be a bunch of milliliters in 1 liter because milliliters are smaller. So how many milliliters are in 1 liter? 1,000. Okay, so we're just going to cancel our units. So we end up with liters. And if we summarize or simplify this, we get 125 divided by 1,000 liters. Okay, now you could plug this into your calculator, or, if you are really good at this type of math, you might automatically say, oh, that's 0.125 liters. But sometimes I still plug it into my calculator, especially if I haven't quite woken up my brain yet. Okay, so that's the volume of solution in liters. So now in the next step, we're going to convert that into moles of aluminum chloride. All right, so we want to end up with 0.125 liters of solution, which is equal to 125 milliliters. But now that we have the right unit, we can cancel it with our molarity unit, and we'll end up with moles of aluminum chloride. Okay, so in this one, I am going to use my calculator. Okay, so 0.125 times 0.15. Okay, so I get 0.01875 moles of aluminum chloride. Okay, so that's how many moles of aluminum chloride we want to add to our solution. But we were asked to figure out how many grams of aluminum chloride we need to add. So now we can go on to our third step. So in our third step, we're going to convert moles of AlCl3 to grams. And remember, we need the molar mass in order to do that. Okay, so let's calculate the molar mass of aluminum chloride. So I'm going to pull up my periodic table on a separate device here. So if you want to pull out your periodic table and follow along, you can. Okay, so in aluminum chloride, we have one aluminum atom. And let's see, the mass is 26.98 grams per mole. And I'm going to add 3 times the mass of chlorine because we have 3 chlorines. And that mass is 35.45 grams per mole. Okay, so I'm going to plug that into my calculator. Let's see, 26.98 plus parentheses 3 times 35.45. Okay, I get 133.33 grams per mole. Awesome. Okay, so now we can take our 0.01875, I believe it was. Let's double check. Yep. Moles of aluminum chloride. And we're going to use the molar mass to convert from moles to grams. So, do we want grams to be in the numerator or in the denominator of our conversion factor? The numerator. So we're going to put 133.33 grams of aluminum chloride in the numerator, and we'll divide that by 1 mole of aluminum chloride. Okay, so now we're just multiplying across. So 0.01875 times 133.33. Okay, I get 2.50 grams of aluminum chloride. All right, so does that match one of our multiple choice options? Thankfully, yes, it matches C. Okay, so this was kind of a longer problem. Now, you also didn't have to do all of these individual steps. You could have also done this all in one long calculation. So on the solution slides, we have our plan to convert from liters of solution to moles to grams. So they're kind of skipping that step where we converted from milliliters to liters. I still like to write those steps out just so I don't make any mistakes. But then once they had liters, then you could convert that to moles and then to grams. All right, and then here are the conversion factors we used. And again, they kind of had one long calculation here. So that's okay too. But if you like to go step by step, no problem, as long as you get the right answer. All right, so we just used molarity as a conversion factor. Now, when chemical reactions involve aqueous solutions, kind of like the one we just talked about, aluminum chloride, we use the balanced chemical equation, the molarity, and the volume to determine the moles or grams of the reactants or products. So that's exactly what we just did, but we weren't really considering a balanced chemical equation because we were told, we're just making a solution of aluminum chloride. But if you do have a chemical reaction, we're just going to add an extra step in there. So this is very similar to the flow chart that we saw earlier, where if you start with the mass of a reactant, for instance, you can convert that to moles. And we'll do that using molar mass. And then once we have moles of that reactant, we can convert that to moles of something else. using ratios from our balanced equation. And then we can convert moles of B to a mass using molar mass. Okay, but we were just told with aqueous solutions we want to use molarity and volume. Okay, so we're going to add on to this flow chart. So we could start with a volume instead of a mass, and then we can convert that to moles using molarity. And then we could keep going. Once we have moles of A, we could convert that to moles of B, and then convert that to a mass. Or another option, if we start with a volume of A, and then we use molarity to convert to moles of A, we could convert that to a mass for A. Okay, now what if we end up with moles of B and we have a concentration for B? We could convert that to a volume of B. So if we just have all aqueous solutions. So now we're expanding on our tool set. So not only can we use molar mass to go from moles to mass, we could use molarity to convert between moles and volume. So now we're expanding our tool set, and we have all of these different options for how we can perform different calculations. So let's practice doing that. So we're going to use that expanded flow chart. So let's say that zinc reacts with hydrochloric acid to produce hydrogen gas, H2, and zinc chloride, ZnCl2. So notice that there are aqueous solutions here. We have hydrochloric acid and zinc chloride, but we also have a solid. We have zinc, and we have a gas, hydrogen. And let's say we're trying to determine how many liters of a 1.5 molar hydrochloric acid solution completely react with 5.32 grams of zinc. Okay, so it looks like in this problem we're just concerned with hydrochloric acid and zinc. So we're not going to worry about the products for this problem. All right, so now let's write out what we're given. Okay, so we're told that we have a 1.5 molar solution of hydrochloric acid. So I'm going to write that as moles per liter. And then we're starting with 5.32 grams of zinc. Okay, and then what we need to determine is how many liters of the HCl solution do we need to use in order to completely react with all of that zinc. Okay, so what we probably want to do is write out a flow chart. So if we go back, we're starting with a mass of zinc. So that means we're starting here on our flow chart. Okay, so then what we need to do is figure out what our endpoint is. So if we go back to our problem, what we need are liters of solution. Okay, so we're going to try to end here. So we're trying to figure out a volume of hydrochloric acid. All right, so now we're just going to follow our flow chart. So we're just going to go all the way across, but when we hit moles of B, we're going to go down to volume. All right, so we're going to start with the mass of zinc, and then we're going to, and actually let me, I'm going to write in zinc here. Okay, so we're going to start with a mass of zinc. We're going to convert that to moles of zinc using the molar mass of zinc. Then we're going to convert that to moles of hydrochloric acid. Using the ratios from the balanced chemical equation. And then we're going to convert that to a volume of HCl using the concentration of the solution, or the molarity. All right. So hopefully this flowchart helps a little bit with kind of organizing your plan of attack on this problem. And you can use this flowchart for any of the problems we do. You know, let's say you were just trying to convert from moles of zinc to moles of hydrochloric acid. You would just use that middle part of the flowchart. Or if you were just converting from mass of zinc to moles of zinc, you would just use that part of the flowchart. Now, since this is a longer problem, we're using a much larger portion of this flowchart, but it all works. So, you know, hopefully this kind of helps you organize your thoughts. Okay, so let's follow this plan of attack here. All right, so I'm going to rewrite that flowchart. Okay, so first step, we're converting from mass to moles for zinc using the molar mass. Then we're going to convert to moles of HCl using the coefficients in our balanced reaction there. And then we're going to convert that to a volume of HCl using molarity. Okay, so again, this is one more tool we have. If we're using aqueous solutions, we can use molarity instead of molar mass. Okay, so now we can actually just go straight across and solve this problem in one long dimensional analysis. So starting with the mass of zinc, 5.32 grams. Let's look up the molar mass of zinc on our periodic tables. So zinc has a mass of 65.38 moles per, or grams per mole. Let's see, 65.38 grams of zinc is equal to 1 mole. All right, so for this first conversion factor, do we want grams in the numerator or the denominator? In the denominator, we're trying to cancel grams, right? So we'll put 1 mole in the numerator. Okay, so that's step 1. And in step 1, we're canceling grams of zinc to end up with moles. Now, in the second step, we're going to convert from moles of zinc to moles of hydrochloric acid. So this is where we use the coefficients from our balanced equation. So it looks like there's 1 mole of zinc for every 2 moles of hydrochloric acid. Now, do we want moles of hydrochloric acid in the numerator or in the denominator? In the numerator, so we want 2 moles of HCl in the numerator and 1 mole of zinc in the denominator. Okay, because they react in a 1:2 ratio there. Okay, so we're canceling moles of zinc in that step. And then in the last step, we're going to use our molarity of hydrochloric acid to get to the volume of hydrochloric acid solution. All right, so we were told that there's 1.5 moles of hydrochloric acid for every 1 liter of solution. All right, so let's kind of write that out up above. So 1 liter of solution is equal to 1.5 moles of HCl. So do we want moles of HCl in the numerator or in the denominator of our conversion factor? The denominator, because we're trying to get rid of moles of HCl. So we'll put 1 liter of solution in the numerator. Okay, so we're canceling moles of HCl. All right, so our final unit will be liters of solution, which is exactly what we're trying to figure out. How many liters of a solution do we need in order to react with zinc? And let's simplify our numbers here. So in the numerators, we have 5.32 times 1 times 2 times 1. And I'm just leaving out the ones because it gives us the same answer. All right, and then in the denominators, we have 65.38 times 1, so I'll leave that out, times 1.5. Okay. So now let's plug this into our calculators. So 5.32 times 2 divided by, and I'm going to put parentheses around everything in the denominator, just so my calculator knows exactly what I'm doing. Okay, so we're going to multiply those two values, and we get 0.108 liters of solution. All right, so that's how much of our hydrochloric acid solution we need in order to completely react with 5.32 grams of zinc. So maybe we're trying to just completely get rid of that amount of zinc. All right, so this was a longer problem. It was definitely more involved, but if you have that flow chart handy in your head or on a piece of paper, you can just follow that flow chart to figure out what you need to do. Oh, and then there's a blank slide. Okay, so here are the solution slides if you need those later. And this just shows the same calculation we did, and we got the same answer, so that works out. And here's that same flowchart that I drew earlier. So we've talked about how to convert between mass and moles, and then also volume and moles using molarity. Now you can ignore this gas section. We're going to talk about that in Module 7. But the main thing to notice in this flowchart is that you always have to go to moles first. So you always have to convert to moles before you can convert to anything else. What's also nice is that you can kind of do whatever you want here. If you're starting with, let's say, volume, you can convert to moles, and then you have 3 different options. So you could go up to mass, you could go down to volume, and in the next module, we'll see that we can convert to volume of a gas as well. So there's all these different ways you can go and all these different tools you can use. But the main point is you have to go through moles. You can't directly convert from mass to volume or mass to mass. You always go to moles. So really, that's also my main piece of advice when you're doing these calculations. If you're not sure what to do first, convert to moles. And then from there, you have a ton of different options. All right, so on Canvas, I posted a concentrations worksheet. So definitely use that as a practice and study tool. Now, normally in class, I would have you work with your neighbors and just make sure you're getting the same answers. But I posted the key so you can consult that as you go through the worksheet and just make sure you're getting the same answers and, understanding how the problems work. Now, again, if you have any questions, always feel free to email me or set up an office hour. You can also contact the Writing and Tutoring Center. They're also super awesome. And in the next video, we're going to talk about dilutions of solutions. So we'll go over some calculations for dilutions. I will see you then.